Hi. In this video, we will see how the determinant of a 3 by 3 matrix can be computed. Okay, so we have a 3 by 3 matrix. So it will have entries A11, A12, A13, then A21, A22, and A23. A31, A32, A33. So we want to see what is the determinant of this guy. So first of all, we will go on the first row, and what we do is this. Pick one by one these entries. A11, A12, A13. Then you multiply, so there's another thing. You put signs. For the first one, it will be plus, second one minus, the third one again plus. Alternate. Starting with plus, then go back there. Okay. Each one of these guys is going to be multiplied by determinant of a 2 by 2 matrix. What is that 2 by 2 matrix? For each one, this is a different one. This is given by what? So for A11, you delete basically or cover row 1 and column 1. The rows and columns that A11 belongs to. Okay? So here, this will be A22, A23. A32, A33. Nice. That's the first determinant. The determinant that we need to multiply to A12 obtained by deleting the rows and columns of A12. So delete the first row and second column. The remaining is a 2 by 2 matrix, A21, A23, A31, A33. And for the last one, A13, you delete the first row, the first row and the third column. So it will be determinant of A21, A22, A31, A32. So this, now that you have 3 2 by 2 matrices, you can compute the determinant of each one, and the number you get out of this computation is the determinant of that original 3 by 3 matrix. At the end, we're going to get a number. That's very important. Okay, let's do some examples for this. Okay, so this is an example for these ones. 3 by 3. So how do we start? Okay, so we go with the first row. The entries of first row, 2, 1, and 3. And then don't forget the signs, plus, minus, plus. Then each one of these entries are going to be multiplied by a 2 by 2 determinant of a 2 by 2 matrix. What are these 2 by 2 matrices? For the first entry, you cover the rows and the row and column of that entry. The remaining is, you see here, 0, 2, 1, 4. That's the first 2 by 2 matrix. Then the second one, the second entry of the row 1, so you cover row 1 and column 2. The remaining, you see here, 1, negative 1, 1, and 2, 4. And we are going to find the determinant of that guy and then multiply by negative 1. For the third entry, we have the third column and first row. So here you have -1, 0, 1, 1. And this is the computation that we have to complete. We know how to compute determinant of 2 by 2 matrices. See here, 0 times 4 minus 2 times 1 minus 1 times -1 times 4 diagonal minus 2 times 1 of diagonal plus 3 times diagonal -1 times 1 minus of diagonal 0 times 1. And then compute these numbers. So this is 2 times -2 minus 1 times, this is what? This is -6. And the last one is plus -3. So what we have is -4 plus 6 minus 3, which altogether gives us a -1. Okay, so the second example. Now, again, we go one by one on the entries of the first row. Don't forget the signs. Then each one is going to be multiplied by determinant of a 2 by 2 matrix. Let me grab this here. Okay, this is determinant of. But what are those 2 by 2 matrix? Cover the rows and columns of the corresponding entry. So this is 2, 2, -1, 3. For the second one, we cover first row and the second column. So then the entries, the remaining entries, form this 2 by 2 matrix. And for the last one, you cover these guys here. This is 2, 2, 0, -1. When you write down this formula, everything now goes back to computing 2 by 2, determinant of 2 by 2 matrices. So first one is 0 times, well, right now you notice here, if you have a 0 entry in the first row, you're going to multiply that determinant by 0. Doesn't matter what is that determinant, it will give you 0 entry for that piece here. So I don't need to compute the determinant of this 2 by 2 matrix. Let me just keep it that way. Minus 1 times 2 times 3 diagonal minus of diagonal plus 3, 2 times diagonal minus of diagonal. Well, let me just write the determinant of this guy for completeness, but in practice, I don't need to write this determinant and compute that. Because whatever is that determinant times 0 is 0 minus, this is 6 minus 0, so minus 6 plus 3 times, what is this guy? Here is -2, so that is minus 6, another one. So this will, the total will be -12. Okay, so well, even if there is a variable in the matrix, we still can go ahead and find the determinant. Yes, so k1 2 1 0 -1, k plus 1 2 1. So go one by one on the entries of first row, plus minus plus times determinant of 2 by 2 matrices. What are these 2 by 2 matrices? Well, cover the rows and columns of the corresponding. So this will be 0, -1, 2, 1. The second one will be 1, -1k plus 1 and 1. And the last one will be 1, 1, 0, k plus 1, and 2. Well, let's then find the determinants of the 2 by 2 matrices. So this is 0 times 1 minus negative 1 times 2 minus 1 times 1 minus negative 1 times k plus 1. And the last one is 2 times 1 times 2 minus 0 times k plus 1. And this gives us what? This guy here is just 2, so this is 2k. Here we have what? This is 1. This is also 1. So we add, we get minus k plus 2. And the last one, this is 2 times 2 is 4. And all together it gives us 2k minus k is a k. And this is minus 2 plus 4, which is plus 2. So the question says for what values of k, this determinant of this matrix is 0. So that means that k plus 2 equal to 0 needs to be solved. So that means that when k is negative 2, then the determinant of this matrix is going to be equal to 0. Well, as you see, the formula is not easy. Let me go back to the formula. And always you have to reduce first the determinant to the determinant of 2 by 2 matrices and then go from there. One last remark is that, let me go back to the original size, but I will keep it this way, that you may have noticed that this kind of things we have done when we were trying to do the cross product. So let me write as a remark. So when we were doing the cross product, we were doing almost the same things with only one difference, that we had when we had the cross product, we had 3 entries there. Yes, we didn't have this A11, we had this determinants and determinants. And remember that the second entry we had always this negative sign there. How did we find these 2 by 2 matrices? Exactly the way we have. We covered the column 1, column 2, column 3. There were no rows. So this is basically what is happening here. The way we found it, this is row 2 cross row 3. And then, well, you see that every entry, the first entry is multiplied by A11, the second entry is multiplied by A12, and the third entry is multiplied by A13. Yes. So this means what? This means that you multiply them and add them. Remember, this is dot product. So row 1 dot row 2 cross row 3 is actually what now we call determinant of A. So this relation is something that you can use and well, at least see the similarities and know that you already seen these kind of formulas. Okay.